Being aware of how many phenomena are beyond our comprehension and ability to control makes physics and space fascinating to us. They aid in our understanding of the size of the globe. Wormholes are one of the things that is both perplexing and fascinating. Doesn't that name seem funny? Worm-caused holes? I'll describe the idea in just that manner. Imagine a worm and a lengthy piece of paper. The worm needs to move quickly from end to end, or A to B. The paper is too long and the worm is too slow, making this task difficult. The worm might quickly get where it was going by simply eating through the paper if point B was positioned below point A. What a wormhole does is this. The amount of time and energy required to travel between two far points in space or time is decreased by creating this hole, which connects the 2 points. According to the wormhole hypothesis, enormous distances throughout the cosmos could be shortened by a fictitious transit through space-time. General relativity makes wormholes a possibility. Be cautious though, as wormholes pose risks such as abrupt collapse, intense radiation, and potentially hazardous contact with unusual materials. Though they weren't initially dubbed wormholes, the theory of them dates back to 1916. Austrian physicist Ludwig Flamm discovered a different solution to Albert Einstein's general relativity equations while examining one provided by another physicist. He talked about a white hole, which is a black hole's hypothetical time reversal variant. There might be a space-time conduit that connects the entrances to both black and white holes. General relativity was utilized by Einstein and scientist Nathan Rosen in 1935 to develop the concept and suggest the presence of bridges between spacetime. These bridges link two distinct locations in spacetime, hence posing the possibility of a shorter route that would shorten travel times and distance. The wormholes or Einstein-Rosen bridges are the names given to the shortcuts. Stephen Su, a professor of theoretical physics at the University of Oregon, told our sister site, Live Science, that the entire thing is really hypothetical at this time. Nobody believes that a wormhole will be discovered anytime soon. According to a paper published in the Journal of High Energy Physics, wormholes have two mouths with a throat separating them, 2020. Most likely, the mouths would be spheroidal. The throat could take a longer course than a more direct route would require, or it could be a straight stretch. Although wormholes are predicted mathematically by Einstein's theory of general relativity, none have been seen thus far. It is possible to detect a negative mass wormhole by observing how its gravitational field affects nearby light. The presence of wormholes with black holes at each end is permitted by some general relativity solutions. A wormhole cannot be produced by a naturally occurring black hole, which is the result of the death of a star. In science fiction, wormhole travel is frequently depicted. Although we haven't yet seen one, the reality of such travel is more problematic in general. The size is the first issue. It is expected that primordial wormholes exist at tiny scales of 10 to 33 centimeters. However, it's feasible that some have grown to enormous sizes as the cosmos has expanded. Stability is a different issue. The projected Einstein-Rosen wormholes would be unstable and worthless for travel. It's unclear whether such matter exists in the universe, according to Su. You would need some really unusual form of matter in order to stabilize a wormhole. A wormhole containing exotic material, however, was discovered to be able to remain open and unchanged for longer periods of time in more recent studies. Exotic matter has a high negative pressure and a negative energy density, which should not be mistaken with dark matter or antimatter. Only in the behavior of specific vacuum states has such matter been observed, according to quantum field theory. According to Live Science, a wormhole could hypothetically be used as a means of transmitting information or travelers through space if it included enough exotic stuff, whether naturally occurring or purposefully created. Unfortunately, trips by humans through the space tunnels might be difficult. According to physicist Kip Thorne, one of the world's foremost experts on relativity, black holes, and wormholes, the jury is not in, so we just don't know. However, there are significant indicators that the rules of physics preclude human beings from traveling through wormholes. That's awful and depressing, but that's the way things are going. Wormholes might link not only two distinct areas of the same universe, but possibly two other universes. Similar to this, some scientists have hypothesized that time travel would be possible if one mouth of a wormhole were to be moved in a particular way. According to astrophysicist Eric Davis, traversable wormholes allow travel into the past or the future. But it won't be simple. To turn a wormhole into a time machine would need a Herculean effort. It will be difficult to pull off a wormhole. However, according to British cosmologist Stephen Hawking, such application is not feasible. According to NASA's Eric Christian, a wormhole is not actually a way of going back in time. It's a shortcut, so that something that was far away is much closer. It's possible that the addition of ordinary matter might be enough to destabilize a wormhole, even as adding exotic matter could stabilize it to the point that human passengers may pass through it without danger. Even if wormholes could be detected, current technology cannot stabilize or enlarge them. However, in the hopes that technology will one day be able to use them, scientists are still researching the idea as a means of space travel. You would require some extremely cutting-edge technologies, Sue added. Humans won't be performing this anytime soon. Which of Einstein's theories came to pass? To learn more, see NASA's article on 10 things Einstein got right. Watch this little excerpt from the ESA film 15 Years of Discovery to see an artist's depiction of a wormhole. Faster-than-light relative speed is only physically impossible where it occurs. By ensuring that the speed of light is never locally exceeded at any time, wormholes might effectively enable superluminal, faster-than-light, travel. Subliminal, slower-than-light, speeds are employed when passing through a wormhole. The amount of time required to travel via a wormhole may be less than the amount of time required for a light beam to travel through the space outside the wormhole if its length is smaller than the distance separating two places outside the wormhole. The passenger would be outpaced by a light beam passing through the same wormhole, though. The many-worlds interpretation of quantum physics provides a potential solution to the dilemmas caused by time travel facilitated by wormholes. In spacetimes with closed time-like curves, David Deutsch demonstrated in 1991 that quantum theory is entirely consistent in the sense that the so-called density matrix may be constructed free of discontinuities. It was later demonstrated, however, that a model of closed time-like curves with such peculiar effects as the ability to discern between appropriate and improper mixtures can have internal inconsistencies. As a result, the destructive positive feedback loop of virtual particles traveling through a wormhole time machine, which is what semi-classical calculations predict, is avoided. A particle returning from the future goes to a parallel universe rather than its original universe. This argues that a potential bridge between current parallel universes is a wormhole time machine with an incredibly quick time leap. This type of communication between parallel universes is consistent with Joseph Polchinski's suggestion of an Everett phone, named after Hugh Everett, and Steven Weinberg's formulation of nonlinear quantum mechanics because a wormhole time machine introduces a type of nonlinearity into quantum theory. Interuniversal travel refers to the potential of communication between parallel universes. The Schwarzschild black hole Penrose graphic also features a wormhole. A faster-than-light item will pierce the black hole in the Penrose diagram and emerge from one end into a new space, time, or universe. This wormhole will connect different universes. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.